ఒకసారి రండి, మీరు రావాల్సింది రండి, తప్పదు రావాల్సింది నమ్మండి. రండి మేడం మీరు.
I've given a number of talks so far in India, and at the last one, I had so many professors ask to take my presentation that we had trouble finding my flash drive today. But unfortunately, I know this material so well that we could recreate fairly quickly. Anyway, my interest is in security and disaster and emergency management. My background is in engineering. But in America, after 9/11, everyone wanted their piece of the Homeland Security research pie. So, like pigs at a trough, I similarly sort of, joined the, public administration movement, which, covers, Homeland Security and disaster studies. Some classic names in the U.S. In any case, this is a very timely and important field, and I can't think of a more valuable connection to 5G than these issues. So I'm going to give a short plug, though. I live in the most beautiful location in the world. I'm actually Canadian. I grew up in Canada, in a small town. My dad was a professor at the University of Waterloo, and we are very proud of our university. We invented the first Fortran compiler, and we have very strong relationships with Bangalore, in fact. So I'm very glad that we can come face to face with some of these leading, innovators. And in fact, next month, I invite you all to my hometown for the 11th Computational Intelligence and Computer Networks Conference with some other Indians. We're also organizing recent trends in computer science and engineering. In any case, it's a great opportunity for students, and if there's anything that catches your eye, if you speak to me, we're very accommodating. You can maybe give a presentation online and still publish in our journals and our proceedings. In any case, we work in collaboration with these different organizations, and it will be in lovely Diamond Head near Waikiki. All right. So what I'm all about is looking at how we can use 5G and other leading technologies to improve emergency services and public safety. And I'm so delighted that we were able to rub shoulders with some leading people from around the world here. I see Dr. Abdul Rahman, who was mentioning his research interests in looking at some inclement weather and how that affects 5G systems. Mr. Professor King of the Earth, Putri Raj, taught me that anyway, he's also very innovative in terms of urban search and rescue and looking for people that are trapped under rubble. So I think we're seeing today sort of a nexus and some synergistic energy all coming together. So a lot of our work involves closed camera TVs, trying to improve what Dr. Param mentioned, situational awareness, and that's not just a buzzword. If you asked people in our industry what's the most important term, they would say using 5G to improve situational awareness, giving some type of a global contextual understanding of the situation. And if there's a disaster, you're not going to be rescued in 5 minutes, in the next 5 minutes, maybe not in the next hour, because the fire department, the emergency services, they have to undertake a triage. They have to do situational awareness. They might even get stuck in their building, and the roads might be difficult to traverse. Anyway, you see we're trying to tie this together with different mobile devices and have high-quality videos and medical data. A lot of people have spoken about emergency services in a disaster. Everyone ends up in a hospital, and there's a great movement towards digitalizing the medical field. We have to prioritize medical and public safety data. So if there's one key take-home message, we talked today about latency issues, reliability issues, but I'd also like to add the public safety component. So in this conference, we come away with safety, reliability, and latency issues. All right, so a lot of our work involves public safety-enabled terminals, and one of the key aspects of disaster management is actually preparedness and public messaging. So how can we try to broadcast these messages in real time? In fact, most of my research was catalyzed initially. We had collaborations between Waterloo and MIT, and Marvin Minsky and other people were absolutely committed to using robotics and leading-edge technologies in disasters, because these are some images from Fukushima, and in fact the robots themselves died in these cooling ponds because of the extreme conditions. So it's really ridiculous to have a fireman enter a burning building, or have the Japanese self-defense forces enter the Fukushima disaster site, when in fact we now have the technologies to allow us to simply use a variety of technologies when we leverage 5G. So urban search and rescue is a key topic. The King of the Earth was explaining to me today about some of his interests in ultra-wideband. Combine that together with what the dogs can do with search and rescue. We've got tremendous potential. We should be able to reduce the accidents, if we had, convoys of vehicles moving together. In fact, if you have any type of smartphone today, your iPhone, Alexa has saved a number of lives. Sometimes people are trapped in their cars, and simply they voice activate an emergency 911 call. All right, we are actually the Hawaii hub in my office for what we call the MIT Fab Lab movement. There were sort of three, broad phases of the digital revolution, right? Computation, communication, fabrication, right? Right now, I fabricated all of these things. So you can, in fact, it's a little bit sad, but you can see if you were actually a victim, you might be able to use that type of fabrication. Very controversial, the use of guns. My students actually printed off the Transportation Security Administration, U.S.'s keys that they use to unlock everyone's luggage. You can print off drones of various sizes. Just think of how this transforms the world. In the old days of disasters, what did you need to do? You needed to, order some pipes, or fix the critical infrastructure, get some steel and tools, and now you can print all these things yourself. This is just bronze powder, very cheap, that we were able to create. If you can use any type of material, bronze, steel, at any type of concentration. So just think of the impacts of this. In the old days, what we would do is you would order these. This is just a cheap pipe I printed off for a few pennies. In the old days, you would have to order it from, Guangdong, and they would have to ship it to the port, and then they would have to, or maybe by train it would go to the port, and then they would ship it to the disaster site in the Caribbean, and you would have all types of time delays, extra costs, pollution. So this really is revolutionizing the world. If you just look at the evolution of speech recognition technology since 1971, you'll see there's all types of beneficial and nefarious uses. You can imagine in the future people are able to simulate your voice. And right now we're just on the edge of writing code so that Alexa can post emergency messages to your whole family. Anyway, we put all of this together, and my latest book is called Extreme Emergency Management, because it combines extreme computation with extreme connectivity, which we're here today, together with extreme manufacturing. Germany is so proud about extreme automation, Industry 4.0. In fact, this book just came out a few weeks ago.
Like Boston Robotics.
Sorry?
Boston Robotics.
Yeah, of course. You can imagine how in the future lethal autonomous weapons are absolutely going to change the world. You get swarms of weapons operated in packs, and so this is my paradigm that the use of 5G will allow us to address issues with high consequence, intelligent autonomous systems together with high task entropy. How am I doing for time? I know we're late.
No problem.
All right. So, anyway, this is so important that we teach this to our first-year students. Okay, so I think it's something that is really important for the world. So, I tell them that, we have no choice because we have to embrace what the previous speaker was mentioning in terms of, multiple participant, multiple criteria decision making. We have to, include everyone in the process. There's all types of, ethical, issues associated with, killing people, in an automated way with our, with our high reliability and low latency and high security systems. So this is what our book is about, the use of 5G and intelligent automation for the emergency management community. The only thing that was bothering me today is I heard a lot of people mention, well, AI is the future. But I didn't really hear anyone tell me what exactly is AI to them, or what they actually do in AI. So I'll explain to you what we do and why it's important. Anyway, so my main value is to combine my background's in engineering, but most of the money comes from National Science Foundation, and they always like to see integrated, comprehensive, all hazards, disaster risk management that involves multiple participants and diverse groups, and the buzzword, sustainability. Anyway, so we bring in both the social sciences and the physical, sciences together in a lot of these large grants. And then you can see, even if you're not interested in anything I have to say because you don't study disasters, just think of all the commercial and home applications for this. Currently there are humanoid robots that can mirror the movements of a human wearing an exoskeleton suit. Elderly people will be able to carry out more tasks with the use of these technologies. And my background is also in group decision making. We were very active in systems man and cybernetics as part of IEEE, and there's a large community of people that are interested in decision support systems, group decision support systems, and negotiation support systems. And there's various ways in which we tie all these things together. And we also have to take into account this as the general structure for multi-criteria analysis. A number of different services that we're using in the emergency profession, various emergency management applications. Many cities are providing this information to the public. So this is saving lives because together with machine learning, they're able to optimize the routes to the hospital, and people are able to understand better, where the evacuation, sites are, and what the historic incidents have been, and then they can try to allocate their resources in a more improved way. We also look at a variety of different architectures that involve end-to-end 5G solutions, including video streaming, software-centric network architectures, and what I wanted to leave you with, and I know I've got at least a little bit more time, right?
Yeah.
A little bit more time. All right. So I need to leave you with is I'm disappointed at this conference only because we have to really understand our limitations. We've got so much energy. I hope that I can come back, and I've spoken to a few people that I want for sure to invite to Honolulu, and yet I think we have to be critical when we're using some of these words, right? So when we're talking about like artificial intelligence, I'm not even sure we ever will get there. I mean, we might be like modern day alchemists. We're still learning about chemistry, and I'm not sure, chemistry will ever move from like, science to a pure, engineering profession. So maybe we don't want AI at all. Maybe it's really just intelligent augmentation to support the first responders. In any case, people do look for the holy grail of what they call generalized artificial intelligence. But I think we have to be more realistic and look at narrow AI. I don't need to read these things to you, but that's what the systems are currently capable of. So I think it's a really virgin territory because there's a lot of pristine areas. Do we think in emergency management we want a system that has a social understanding of an 8-year-old? I mean, well, in the event that there's, let's say, I don't know, a Muslim woman or something, and in their culture you're not allowed to touch them, in certain ways. I think the systems have to be sort of intelligent when they're undertaking some type of medical evaluation. I don't know that the manual dexterity of a 6-year-old or the object recognition of an infant is sufficient. Anyway, these are very basic movements that even a young child can do that currently the 5G robotic systems are unable to carry out. So I've spoken to a number of people here today that have done some research in neural nets. I actually started off in the hard AI approach, the symbolic approach, and I want to think critically about how we can get to generalized AI if possible and the role of 5G. So maybe I'm being too ambitious, but if you want to correct me, this is one way to categorize artificial intelligence categories. The symbolic approach was started with Minsky in 1956, and I've provided 3 other categories here: the soft AI approach, so the soft computation, and traditional and more contemporary robotics approaches. All right, symbolic approach, I think we understand has major failings, right? You've got all types of if-then statements. So but it has turned out to be in some ways cataclysmic failure because the symbolic approach has the symbol grounding problem, right? So if we want to define, who is the president of the United States, we would have these sort of if-then statements, but how do you even define what's the United States or what's a president? Anyway, so the people have moved away from AI. Neural networks, were all the rage, right? Fuzzy neural systems. But I think people have sobered up recently. This caption you might remember from 2014, it caught the world by storm because people said, wow, we don't even need professionals anymore. This is an example of a caption that was created by an automated reporter. And the caption automatically was able to view the image and to create this title. And so people thought, well, new neural networks are going to change the world. But in our experience, they're relatively, inappropriate for emergency management decisions because you need large, training data sets. Sometimes they're computationally intensive. And they really have no knowledge outside this very narrow AI sense. So we know that it can tell us that this is, people playing Frisbee, but does the system know if you can eat a Frisbee? Does it know if you can drive a Frisbee, how much a Frisbee costs? It knows nothing. So I'm not sure that's the best use. And you saw my previous slide, there are very fits and starts for neural networks. Some people gave up, and then there's been a more recent renaissance. Traditional robotics approach, going back to the 70s, includes both the symbolic and innovations in GIS and spatial information. We're more interested in the behavior-based, sometimes called the enacted, embedded robotics approach for 5G. And MIT has collaborated with us to look at applications for their Cheetah 3 system, and it's extremely powerful because you would think that you would need vision for a behavioral-based, robotics approach in 5G. But in fact, humans are able to walk without vision, right? I could probably safely walk across that stage just with my eyes closed because of I think we call it, blind locomotion, proprioception. You're able to, touch your nose with your eyes closed. So if you combine that sense of proprioception, which is now there for the first time, together with 5G and, of course, pattern recognition and computer vision, you really are changing the game. So we were talking about, multiple criteria. Each of these AI approaches have some advantages. The behavioral-based approach is coming close to having true intelligence or sentience. All right, so the other point I just want to make, though, is that when we're talking about, AI and 5G, the child, is still, ranking, about 100 relative to even the behavioral-based approach, which might score a 3 on intelligence or understanding some type of sentience. All right. So the other really exciting things is we can now leverage the strength of people around the world. That was another theme that I heard today. So when we're undertaking, telesurgery, we're now about almost 20 years into the first, remotely operated, surgery that was performed locally by doctors. But also, remotely, you could bring in surgeons and specialists from around the world. All right, so all of this, requires, 5G together with the vast computing and cloud edge computing as well. So you've got here, some examples of the robotic surgery, and so you can now, in the future, save people's lives that are in the field. The doctor has the opportunity to have a virtual experience and actually feel the bones. At the same time, as I said, we've got these additive manufacturing systems with MIT. So our Fab Lab is able to create these bones and tissues actually in the field. All right, so here's some other examples. And so what we're doing is we're trying to create entire ecosystems of robotics together with edge cloud computing. Of course, when we're looking at multiple robots together, sometimes we've got issues with with interference, especially when we're dealing with wireless communication. And this is sort of a summary of some of the 5G areas we were talking about today. And I tend to take a broader approach. I think we have to look at, how can we use 5G to, not just deal with, individual crises, but to address, what we call institutional entropy or rigidity, and try to look at, sustainable systems on a broad scale. So the root causes or antecedent conditions for crises are typically things like, a lack of education or, groups that don't have access to power or resources. So we're moving away from sort of, human and state security and crises towards more broader, environmental and energy security. And so this is just one example of a project that we have. We're in Hawaii, so we've got lots of, environmental case studies, and I was very happy to go to Dehradun in North India because it reminded me of the nature that I have every day. Anyway, so one of our big problems is we've got a lot of invasive trees, and these trees, when there's even a small storm, even a light rain, like Dr. Abdul Rahman was talking about, some inclement conditions, even when you have very light cloud or even light rain or wind, these trees topple over and they take down the power system, they land in schoolyards, they destroy your homes. So we have to embrace the local stakeholders, find ways to use 5G to address these crises, and ultimately we put together some type of a holistic disaster risk management system. And our broad approach is, how can we use 5G for our own, local problems? So the biggest problem we have in Hawaii is we've got a lot of Pacific Islanders, people from Federated States of Micronesia. America sort of has hegemony over the Pacific, and so in return we've got a compact agreement. The poor people from the Pacific Islands can live in the United States. They might not be citizens, but they can live there. Anyway, so there's a massive housing crisis of Polynesians and other Caucasians that don't have any housing because it's expensive. So what we're trying to do is to use 5G together with CNC, computer numerical control, CAD design. I was talking to some other Indian institutes about this, and we're trying to use those trees instead of using them as waste, as a hazard. We're trying to use them as a bounty, as some type of a resource. In the future, what we're trying to do is to deal with natural disasters, and ultimately use 5G to deal with climate change, refugees, and increased sea level rise. And in all of this, we try to apply multi-criteria analysis. So, for example, we're trying to find some use for those trees, and what we did is we were using 5G together with CNC, and we were actually able to create matchsticks, some low-valued products from it, some building materials. Other uses were for burning it, and we carried out a multi-criteria analysis. So this is also sort of a high-level view of sort of my philosophy. In the old days, we were exploiting the environment, and now we're moving towards recognizing that environmental systems are inherently complex. To deal with disasters, we need to embrace 5G, fully autonomous systems, AI, intelligent robotics, to truly capture the complexity and uncertainty of real-world systems that lead to these crises, emergencies, and disasters. Okay. Thank you.